This is the first of several segments in which we'll look at the SQL for adding, modifying, and removing data rows, and for altering the constraints and column structure of existing tables. We'll use a new database representing a university enrollment system. It'll have tables for course sections and for the people taking and teaching them. Across several lecture segments, we'll evolve it into a more complex database, similar to one you may have seen in the labs. And we'll introduce a variety of database modification statements as we go. Now, start by loading the courses1 database, courses1.sql file, as I'm doing right here. And then let's do a select star on each of its tables, and then we can also check out the courses1 er.pdf file for an ER diagram of the database as well. So here's select star from person, for instance, and select star from section. And to get some context there, let's look at the ER diagram. What we have is a person table, which holds both teachers and students. And then the columns major, for instance, and units completed and department all have some null values, as you can see in the listing here, depending on the row. As discussed earlier, null indicates not known or not relevant. In the case of person, the major and the units completed columns apply only to students, but not to teachers. And the department column applies to teachers, but not students. And you can tell which is which by the null values. So quick question one here. Is anyone both a student and a teacher? And the answer is yeah. We have Josette Slingland, who, as you can tell, has no null values for any of those columns. So she is both a teacher and a student. Now, Courses also has a section table of course offerings, or sections in academic speak. Each section is taught by one person and taken by others, and the join tables, teaches and takes, represent those two N-to-M relationships, respectively linking teachers to sections and students to sections. And then finally, term over here holds academic terms, including their name, like fall 13 maybe, and their start and end date. Every section belongs to some term, linked by the term ID, foreign key, in section right here. Now, question 2. How many sections is Ms. Slingland the teacher of? Are they taught in the same term? Is she taking any that she's actually teaching? You can answer this by writing join queries or by just examining the tables by hand. So coming back from a pause here, I chose to use a query. Let's see, select section ID from person teaches section, where person ID equals teacher ID, that's from the teaches join table, and section ID equals section ID, that again is from the teaches join table, and last name is Slingland. And I got IDs 1 and 7, so those are apparently the two sections that she teaches, and I could have made a bigger join there, but I'm a little lazy, so let's just take a look at what those look like, so we can look at the section table. And we can see that's Calculus 1 and databases. Now, she can also we can figure out what sections she takes by doing a very similar query, but this time linking through the takes and making person ID equal to student ID from the takes join table, and then the section ID is similar. And we can see she's taking 3 sections, and they're not the same ones. And I suppose we can get the term information by doing a select star from section and term joined together, where term ID, the foreign key from section, of course, equals term.id. And I'll just use a direct list of the ID numbers in the section.id there, just again being a bit lazy. And we can see that the sections 1 and 7 she was teaching, Calculus 1 and databases, are in fall 13. and also in winter 14, so they don't coincide. And in fact, the 3 she's taking also are in different quarters. Okay, so there's a brief overview of how to use this database. Now let's modify its content. We'll start with updating some rows here. The SQL update command changes column values in existing rows. For instance, let's give Travis Esposito a few more units. So I guess he has 15 of them now. What we'll do is give him 18 of them instead. And we'll do that with update person set units completed equal 18 where ID equals 3. Now this update command takes this 3-part form shown. First the keyword update followed by a table name, update person. And then the keyword set followed by a sequence of one or more comma separated assignment statements, each assigning an expression into a column. For instance, units completed equals 18. And then finally a where clause indicating the row or rows to which to apply the update. And when we run that, we can then see that Mr. Esposito has 18 units. So, question 3. Write and test an update command to change the number of units for the section of Calculus 2 right there, number 3, to 5 units instead. Pretty straightforward. So coming back from a pause, what you should have gotten was update section, set num units equal 5, where ID equal 3. And now it's got 5 units. An update statement's where clause may have the same conditions as a select statement's where clause, and only rows satisfying the clause will be updated. But there's an important point regarding the where clause in any data modification command, whether it's update or especially delete, which we'll discuss shortly. Omitting the where clause makes the command apply to all rows. So try this out. Update person set units completed equal 18. And when we check out the person table, oops, now everyone has 18 units, even the teachers. So we'll fix it by rerunning courses1.sql so we can kind of start over from scratch before continuing. And remember, unless you mean to update all rows in the table, or delete them all in the case of the not yet discussed delete command, you must have a where clause. The whole section is worth, or discussion is worthy here, modifying with care. Modifying databases by hand is much more dangerous than, say, editing a word processing document. Many experienced SQL users develop the reflex of removing their fingers from the keyboard briefly before hitting return on any update or delete command, and paying special attention to the where clause to be sure the command is limited to the desired rows. And many experienced SQL users also run a backup of the database before any database modification session, and even maintain different database logins for read-only and read-write access, using the read-only account if they only want to run select commands, so they can't accidentally modify anything. Now the obvious follow-up question is there an undo in SQL? Control-Z perhaps? Not a chance. Remember, this is 1970s technology. That's the same happy decade that brought you the Unix rm* command. Besides, a typical database is not a private store that only one person at a time accesses. If you're making modifications to a production database, other people or programs will probably be doing so at the same time. Your accidental modification command may be followed by a dozen other changes to the database within a few seconds. This makes reversing your command practically impossible. Say someone correctly updates a unit's completed value just after you hork them all by setting them to 18. If you then return all of them back to the value they had before your bad command, you'll lose that person's legitimate modification. Actually, some modern DBMSs will let you roll back to a checkpoint a few minutes earlier. You might recall the war story regarding this from one of the intro lectures. But this means losing not just your modification, but also any legitimate ones that may have happened since that checkpoint. And besides, MySQL is not one of those databases. MySQL and all other database management systems also let you use a transaction to make tentative changes and then commit them once you're sure. But we haven't covered transactions yet, and there's still no undo once a transaction is committed. So, transactions aside, your only option if you make a disastrous MySQL modification is to hand fix it if you can, or to return to your most recent backup, ideally the one you did just before starting the modification session, and perhaps lose some legitimate modifications as well. The very best strategy is not to mess it up in the first place. Now, let's discuss a few other update forms here. You can change several columns in a single update by listing multiple column assignments. Let's change Juliet Logan's major here to computer science, and also give her 180 completed units. And you can see that that went through there. Now she's got a finished CS major, and that should certainly improve her job prospects. You can also put expressions on the right-hand side of the assignments in an update statement. Let's give everyone 1 extra unit. Thus. Should that have had a where clause? At first glance, no. We said we'd give everyone an extra unit. But does that include teachers? They have null for units completed. See, you really do need to think about the where clause. Now, as it turns out, we're saved by the behavior of null in this case. Everybody did get a increased by 1, but the teachers didn't. It turns out that adding 1 to null yields null. So you can see by checking this new content that the teachers all still have null for units completed. Any mathematical operation that includes a null operand results in null, not error. Per usual, this makes sense if you remember that null means unknown. Obviously, an unknown value, plus 1, is still an unknown value. Now, question 4 here. While we're on the topic, let's try listing just the teachers by doing the following here. Select star from person where major equals null. No rows match. But clearly there are rows for null for major here, right there. Recall the discussion on null from the prior topic and explain why this makes sense. What would happen if I did a comparison with not equal to null instead? Would I at least get the student rows? How can I test for null major values? Coming back from a pause here, in a prior topic, we discussed the fact that any comparison with null produces false. You can't really say that an unknown value is or isn't equal to some other value, even another unknown value. So returning false is the safe choice. This means that the test for major not equal to null is also going to fail and will return no rows. Now, the only way to test for null major is by testing where major is null. And then you can see that that works. Now, let's talk a bit about updates that violate constraints. The same database management system that will cheerfully let you wipe out a million-line table by omitting a where clause will nonetheless reliably reject any update that would violate any declared constraint. Let's try changing Juliet Logan's ID from 1 to 2. We get an immediate complaint about conflicting primary keys. Column ID is a primary key per the create table person statement, and value 2 is already in use by another row. 2 rows can't have the same primary key value. Now, let's try something else. Let's see if we can set Juliet's gender to null. Yeah, again, no go. And not because it's illegal in general to assign null. You can do that. But not to a column with a not null constraint. Let's check out the gender declaration here in courses1.sql. And you can see that it's declared not null. So here's question 5. Can I set Juliet's ID to null? Why or why not? Try it if you like, but reason out what you expect it to do first. Coming back from a pause then, this update here is what we're talking about, and in fact it's not going to work. Recall from the discussion on primary key constraints that a primary key may not be null. If it had been a unique key, however, then null would be allowed. And so you can see that we aren't allowed to do that. Okay, let's try changing Art's IDs, number 2 there, from 2 to 11. Now, that should be okay because no other row has ID 11. Nope. Another constraint error, this time involving the foreign key constraint that teaches teacher.id has to refer to ID from person. A little kind of gibberish there, but that's what it's complaining about. Now, if you think about it, that makes sense. There are rows in table teaches that have 2 for teacher ID. A couple of them right there. If we change R's ID to 11, then those teaches rows will be left dangling. So we should see the same effect from changing Ducalo's ID, which is 10 to 11, all right? The student ID foreign key in takes won't like that. Ducalo is a student, of course. Now, before we try it, let's show the current content of takes so we can see what rows will be affected. There's several of them in there with 10s, right? So we try update person's set ID 11, where ID equals 10. Huh, and it works. Well, let's check that takes again. And all the 10 values in student ID column got changed to 11. So they still point to Ducalo's row. There's question 6 then. Looking at courses1.sql and the foreign key declarations in general, why do you think takes.studentID behaves differently from teaches.teacherID? Coming back from the usual pause, it's that onUpdate cascade modifier. Teaches doesn't have it, but takes does. OnUpdate cascade right there. Now, a bit of research shows that this means if the target primary key value changes, then automatically change along with it. That's kind of convenient. There are in fact 3 ways that the DBMS can handle the case where you alter a primary key out from under a foreign key. The default is to treat it as an error, like teachers.teacherID did. The cascade option alters the foreign key to match the new primary key. And in question 7, this is stuff you should know how to find in the references, so look up the third option, please, if you didn't already in response to question 6. Coming back from a pause there, the third option is set null, and this sets the foreign key to null, in effect marking a broken link. Now, that wraps up our initial explanation of update. Later we'll look at still more powerful forms of the command, and in the next segment we'll look at inserting entire new rows into tables.